The topic I chose to focus on for this astronomy research project is the James Webb Space Telescope. For reference, it is also known as the JWST or the Webb. To preface my research, I wanted to share this quote provided by NASA's website about the Webb. Webb will be the largest, most powerful, and complex space telescope ever built and launched into space. It will fundamentally alter our understanding of the universe. So what is the Webb? The Webb is an orbiting infrared observatory that will be placed at the Sun-Earth Lagrange Point 2, about 930,000 miles away from Earth. It is a collaborative mission between NASA, the European Space Agency, and the Canadian Space Agency, and is expected to continue for 5 to 10 or more years. NASA believes it will extend and even enhance the possibilities of their original Hubble Space Telescope, also known as Hubble, because the Webb is 100 times more powerful. This is because it has a longer wavelength coverage and a greatly improved sensitivity. So, many of the things we have always wondered about how literally everything came to be could be resolved little by little with this Webb. This is what the longer wavelengths will allow us to do. Now, having access to this new piece of technology comes with a cost. So, this is the average cost of producing the Webb. $9.7 billion is a lot of money. Before diving into how it was constructed, I want to show an image of the James Webb Space Telescope as a whole. And now, we will investigate how it came to become this product. Because it took over 20 years to make, I would also like to share just a brief overview of the recent updates on creating the Webb. In August of 2019, the Webb was located and being worked on in a Northrop Grumman facility in Redondo Beach, California. There, they connected a foldable sun shield to the Webb. This is basically like sunscreen to keep all of the instruments inside from overheating while in use. They also used a crane to lower the telescope assembly onto the Webb's overall body. On the right, you can see an image of this operation being done. At this facility in California, the Webb became officially completely assembled after connecting its two halves and testing their connectivity. The Webb has not actually been launched yet. It has been in the process of creation for a very long time, over 20 years actually, because of the numerous delays and setbacks, including financing issues. As time has gone by, the price to create the Webb has doubled many times, but I think it will all be worth it in the end because it is scheduled to launch next year. It will be launched on an Ariane 5 rocket out of French Guiana. Because the Webb is so large, it will fold into the rocket and then unfold after it is launched into space. There are so many possibilities with this new piece of science technology. For example, we could look for other signs of life in other planets or galaxies. I find it sort of odd but very interesting that in the next couple of years, we might find out that we really aren't the only large group of humans. Another goal is to study how the first stars and galaxies were formed, and every phase in between. NASA states that it will be able to go back in time over 13.5 billion years in order to do so. By doing this, it will allow astronomers to compare the earliest galaxies to the present collection in order to understand how they were assembled and such. We will also be able to watch little stars and solar systems being born because the Webb will be able to see right through the most opaque cloud storms. Overall, so many doors will open next year to unleash a new set of discoveries and journeys for us. These are only a few. There are many instruments on board the James Webb Space Telescope. The first is its primary mirror made of 18 separate segments consisting of ultra-lightweight beryllium. Each segment unfolds and adjusts after launch. It also has a 5-layer sun shield, as I mentioned earlier. It is as large as a tennis court and prevents the Webb's instruments from overheating. It also has another cooling system called a cryocooler, which specifically cools the mid-infrared detectors of the mid-infrared instrument to -447 degrees Fahrenheit. The Webb has 4 main or core instruments: the mid-infrared instrument, the near-infrared spectrograph, the near-infrared camera, and the fine guidance sensor or the near-infrared imager and slitless spectrograph. The mid-infrared instrument has a camera and a spectrograph that can see light in the mid-infrared region of the electromagnetic spectrum. This allows the Webb to see the red-shifted light of distant galaxies or new stars. Another instrument on board is the near-infrared spectrograph, which has microshutters that are programmable and allow the Webb to observe up to 100 objects at the same time. The near-infrared camera is the Webb's main imager that covers the infrared wavelength range 0.6 to 5 microns. It will be made so that the Webb can detect light from some of the first stars and galaxies. It also has the capability to take pictures of very faint objects around a very bright large object. Finally, the fine guidance sensor or near-infrared imager and slitless spectrograph gives the ability to point very precisely when taking images. With this, objectives such as first light detection and exoplanet detection will be made possible. To go along with my previous explanations, here are some images of the 4 core instruments. To conclude my presentation, I want to share what I found most interesting about the James Webb Space Telescope. In elementary school, I remember learning about Hubble and getting on its website. I thought it was the coolest thing ever. So, learning about the Webb was super cool for me because of all the advances and new things it could discover. I think overall, understanding what the Webb's instruments are and what they do was the most interesting part for me in my research. I love how there are 4 core instruments, but they all do such complex things that are different from each other. This is my reference page. Thanks for listening.